Hello everyone, Michael the Mechanical here with a hot vlog 3. Today I've been working on a video. Oh look, it's charging. I've been working on another video essentially decking the block again but manually. It's a way they don't recommend about doing, but I have a method for how I'm doing it. You can probably see the scratches still in the block here. There was one here but it's pretty much gone now. There's a bunch here. You can actually clearly see it when I throw the light on there, which is hiding now. So that's nice. If I find the light, I'll try to show you guys so you know how it actually looks. But I'm doing this to save myself some money because I don't actually have the money to go and do anything anymore. I'm gonna sneeze. Oh. Yeah, that's sneezing alright. So there's still scratches over here. There's no scratch in there anymore, so that's gone. Here, there's some scratches every now and then. Some scratches over here. So there's two right there. One of them's actually almost gone, like it's starting to come out. So that's a good thing. I ended up printing out a chart to choose the right grits. And the chart reads like this. I kept reading it wrong, and I thought it was 400 grit was okay. 400 is 9RA, and the grits you want between is 15 to 60 RA finish. So 15 is perfectly fine. I'm going to be using 240 to finish the job. I was using 400 all yesterday, and I got that scratch out that was in between the boards yesterday, so that's a cool thing to know. It's not the right way to do things, but I'm doing it that way because of the budget. I don't have the money to go and do things. But even after doing this, what I'll be doing is I'll get the gauge. I'll be checking for clearances less than the tolerance specified, so it has to be within a certain tolerance for it to work. I'm going to be checking against it again and making sure it's, you know, at the tolerance or less than the tolerance. You know, within tolerance, okay? It's got to be level. And if there's a slight banana in it, then it's no good. And if that is the case, then I'll figure out how to unbanana this. Because this has to be dead level for an MLS head gasket. I'm trying to do it the wrong way. And that's the way I'll say it. I'll say it's the wrong way to do this. So I've still got parts coming. Don't know if it's going to come today. I've got a meeting today. So on and so forth. Also have to make the dowel pins for the block, and essentially the plan is once that part of the block is done, the part where, you know, you gotta get the, what do you call it, I was thinking to myself, once the dowels are in, once the block is decked, I'll put the head on with the MLS gasket, because the reason I was thinking of doing that is there's less chance of damaging the surface. But I just realized there's a problem with that idea, and the problem might be the fact that I still got to put the right gear sets on. So here I got to put gear on, here I got to put a gear on, and the cam still needs correct gear, and all the gears that I need / want, whatever, are all still in here. So I have to start disassembling this and get those gears out so I can put everything together on here correctly and the way it's desired. So I'm not sure what I'm gonna do yet. Oh look, I didn't cover this up last night. So I uncovered this because I was taking some pictures of it. I was gonna upload them to the Boss Garage because my car, I said it was driving and running, but since I've been working on the motor and doing stuff, I decided I'm gonna say, talk against it and say it's not running and whatever, because it's got a engine recon rebuild thing going on, and yeah, keeps blowing head gaskets, so I'm starting the project. I already said, I think in the last video, turbo wastegate manifold is junk on my car. It's no good. This thing was jammed up, freed it up, and it's got some resistance. In here, the manifold's cracked down there, facing that little lever. So that's the case in point there. Now, there's my block, there's my emery that I've been using, and the motion I've been doing is like so. And when I go over here, lift, bring it back, lift, bring it back, lift, bring it back. You know, it's sort of that motion, but it's easier to do when you're actually doing it. So I go down, drag, up, back, down, drag, up, back, down, drag, and I just keep doing that motion. Like it's sort of something like that. And I was doing about this much at a time. So it's about a centimetre, not 5 millimeters. So every time I was picking it up, it was half the distance here. That so it's about that much that I was moving backwards. So that's my cut with my paper, my grit. I'm going to do this as properly as I can, but within my limitations. But when I get a chance, I got to start cleaning up as much as I can again. Once I've got as much of this together as possible, this bench has to essentially go out the door, like out here potentially, because it just takes up too much room in the shed. Dad wants it back down there, but you know, I want to not do that yet. Even though he's like, it's my table now. I'm like, nah, I'm not putting my table back down here. I'm not putting my toolbox back down here, but it's taking up a lot of room. Like now, all this stuff's taking up room. And like I said in another video, I think, I can't use this on here to deck my head properly, so, because I can't really take, the reason I'm doing it the way I'm doing it, guys, just to make it clear in case it's not really understood, why Michael, are you using a block of steel with emery to deck your block and not taking a machine shop? The problem is, to get that to the machine shop is the biggest problem. I got two utes, right? Neither of them are now running because the manifold is still not back on the Tata, so that can't be driven. And I can't register it because I can't afford it. And two, the Triton has the tray. I could put it on here, I could take it to the machine shop. But what's the major problems? One, I've taken out the injectors. Two, the turbo's been removed. And three, I've removed the wastegate blow-off valve thing. And that wastegate is junk. So, do I really want to put new injectors on an old car with potentially a not great injector pump? Don't know the condition of that injector pump. At the moment, I'm thinking I'd rather bide my time, save up, get those things done properly before I put them on the car. The other thing to know, there's only potentially one risk I'm willing to take, because I know I can do it to some extent. I'll try to even build the tool to check things and make sure everything's right. I'm going to rebuild the turbo. The reason I know I can do the turbo is because we've got the tools to do it, and I've been reading and researching into dynamic balancing. So, and I've also been told by the shop that would rebuild this, it would cost more than buying a new one. Like, yeah, they could do it, but it'd cost you more than if you bought a brand new turbo. And they said, don't hit these fins on a hard surface, and it keeps falling over like that, so it's hard. This chair is freaking hard again, so that doesn't help. So they said, don't let these fins touch a hard surface, and because it's been rubbing, they're concerned that these blades have been flexing back and forth more than they should, and they reckon that those blades, if they break off, or parts of it break off, then this will throw this turbo out of balance at high RPMs. It will destroy the, this side, and then it will take out the other side through imbalance. That will get sucked into the engine, potentially doing devastating damage. So that's why they advised against it. But also because when I put this together and I hammered it in, that was naughty. I didn't think about it. I hit the front with the hammer to get this to go into the other manifold, not realizing there's contact points. That's why I've I actually can't see it anymore because I've washed it off. Goose force me. But I put white marker on here to see where it was contacting inside of that other wastegate housing, and it was making some pretty bad contact. So the plan right now is, I'm going to be pulling this apart, And once this is apart, I'm going to properly clean out this area with a wire wheel, maybe some emery paper and some other stuff. I'm going to do the same for the housing over there, the wastegate housing that's over there on the bench. I'm going to rebuild potentially my Triton spin saw kit to see if I can get that to operate correctly again, less vibrations, and make sure it's running right. Then what I'll do is I'll use that to spin the 20,000 RPM tool inside of the wastegate housing to try and clean that up properly, because it's got all these fine metal cracking spiderweb cracks in it where the metal's probably falling off. It looks like the metal's kind of expanded a little bit because it's chipping away, so I'd rather just chip that off, start off sort of fresh with new metal that's not falling apart and flaking off, and then try to put this in there once I've rebuilt it, see how it fits. Depending on which side I've done the best job on, I'll be trying to clean the side I haven't cleaned very well. I'm also going to make sure, when I pull this apart, I put this back onto here the correct way. I put the other side on the side correctly, the right way it came apart. I'm going to try and build a dual plane tester to see about, you know, throwing some RPM on this thing and checking how it's balanced. So what the dual plane tester that I'm going to be using will do, and they're actually very dangerous. I've read why people don't, sorry, I watched a video, guy builds his own balances for different purposes, like it's all about different weighted materials and stuff. So the lighter stuff requires lighter balancing, because if you use heavier stuff, you're not going to see the balance of this. So you have sort of a weird balancing thing where it pivots. So if there's any movement in it, it's hinged from the top and it throws off. I can't remember how, I can't describe exactly how it worked, but I sort of remember it had bearings in it. But it has 2 pins, has 2 holes in a plate, it has a bearing or something that sits on or guides on, and as this is, you know, throwing weight side to side, it's going to rock. And if it rocks the carriage, that's what's called, carriage, then there's a problem. So it was balanced in a really weird way. So okay, you had the balance piece down here, 2 bearings to the solid structure up high, but this structure, which is on its bearing thing, comes up, and your shaft sits on that. So when that rocks, it rocks it like this, and then the bearings transfer the load up, and it can determine where the problem is by doing something similar to that, or pretty much as that. So that's the idea. I'm going to try and build 2 carriages for either side of the turbo to identify where is the imbalance. And then what you do to find the imbalance is, the way you check it, you weigh up some clay and you throw it on the lighter side to see if you can balance the weight off. And once the weight is balanced, essentially, it will not rock. It will essentially not rock at all. And if it does rock a little bit, you keep making changes until you got it right. Then what you do is you take the weight of your clay that you've put on, and you remove it from the opposite side to where you put the clay. And that's the safest way to do it, because if you start removing material at random, you don't know where the material is going to be coming from, then you'll have some issues. So you do that, and then once you're done, you take the clay all off, you've already ground it, and then you balance it again and check how it works at high speeds. And if there is no rocking in the carriages, then it seems like you can use the parts and they're usable. And it should have a long lifetime at that point. However, as the guy said, there's no guarantees about how these blades are going to hold up. They could rebuild this, balance it and everything, but you could still have it, you know, explode on itself or something. But it's a very dangerous machine, and the way you have to operate it, safest way to operate it, is you start off low and you build up speed gradually. So you start off with 0 speed and you slowly build up that speed until there's an imbalance. When it says an imbalance, you try to identify what the imbalance is at that RPM. You add and remove material as required, and you keep going until it is able to operate. You got the thing spinning at the recommended operating speed. So if this is meant to run 180,000 RPM, then you need to get it up to that speed to identify how the balance is of that shaft and those components together. Because if you don't get up to speed, you won't get the numbers you need. That speed is a very high speed. Not even our machines in the shop can get that high speed, and they don't operate at high speed. They operate at high load, not high speed. So building that carriage is going to be dangerous. Operating it's going to be dangerous, and so we're going to have to take precautions. So I'm trying to think of how to show you this machine here. 1400 RPM there, and its low speed is 28 RPM, so it can't get nearly 180,000. The lathe we always operate on, it's scary as anything. There's obviously a bit of lean in the way. I can't even move this because these bottles are heavy. Also, we shouldn't use these bottles. If there's any gas in them, use them, get rid of them, dump them, goodbye. But here, 72 is the lowest, 1600 RPM is the highest. And test speeds for that shaft should be 2500 RPM is what people have balanced them at, from what I've seen. But they would professionally test them at the operating speeds to identify the balance, and you'd build up speed. If you're wondering how I'm going to build up that speed on that turbo to identify how out of balance it is, there's an air compressor there. The air is going to shoot out much faster than anything can spin something at. No electric motors in the shed are going to spin that fast. So the air compressor will have pressure in it, and we'll build up speed with the air compressor by flowing it in or regulating the pressure to the point it's spinning, and then build up the pressure from there if we require that. So that's the idea. Use the turbo as intended. The problem is that would potentially throw off the balance as well. Normally what they do is they put a belt over the center of your piece, and it run based on the speeds that they can drive it at. So something like that. So the way the carriage would essentially work is it would be running on bearings, and the weight of it would be based on, how light is your workpiece you're working on. The lighter it is, the more out of balance you're going to be able to see something is out, and you'll be able to calibrate your components based on how much calibration it requires. Everything has to be perfectly machined, but the idea is the weight, when it's spinning, if the weight has an offset, then the shaft is going to try and pull either or ways. It's going to be trying to pull in all directions. So you'll see the carriage rock that way, that way, that way, that way, that way. The more it rocks, the worse the balance is. So the more heavy your carriage is, you'll be like, oh yeah, she's right, mate. And then the lighter your carriage, depending, okay, let me make it as clear as I can. So if you're working on something very heavy, you need a very heavy carriage to calibrate that component safely. When you're working with something very light, if you're using a heavy carriage, you will not be able to accurately balance something like this correctly. You need a very light grade of, carriage, so then you can see the movement, you can see the off balance of it. So that's sort of the idea of how, in theory, it works. The weight of the shaft is going to push out one way or the other. And if all the centrifugal forces, the dynamic balancing, and the centrifugal forces are in the same location, that's where you want them. That's how it's going to be running at pristine, precision, numerical numbers without ever leaving the center. But as your speed goes up, that balance is going to go out and out and out. It's going to be trying to throw itself all over the place. Weight is one dynamic of your spinning shaft, and then the other dynamic is your material, diameter. So if the material is not perfect, then you're going to have hollows in it. You'll have a bad dynamic balance. Everything needs to be centered. So you have two pivot points. One is your centrifugal force, and then your dynamic force, center of gravity. So if weights trying to spin around the point over here, opposed to your center, which you're trying to spin on. You need to try and line them up. Once they're accurately there, then you can, put it back together and it'll be fine. So this is all interesting mechanical stuff and knowledge and experience, and it's nice to know how to build sort of a carriage, but I don't know how to really use one professionally. But I'll build one, I'll see how it works, I'll make it like air driven as best as I can, just so we can variate the speed. But I wouldn't encourage people to build their own based on what that a guy said in his video about how dangerous this sort of tool is. It's something that I'm willing to take a risk with, but it's not something anyone should just be lightly saying, hey, I'm going to take a risk with this. This is why when we talk about the diesel injection pump, and then we're talking about the turbochargers, I can confidently say, yes, it's possible for me to do the turbocharger because I do know all these variable factors. And it's possible for me to make the tools help me try to do this stuff. However, with the injection pump, that's a lot more harder than a turbocharger. For me, specifically, probably not everyone. And the reason being is because when people reseal them, they don't think about all those components they're wearing out. And I don't have numbers on those sort of things. I don't know what the tolerances are. And if you put them together, thinking, oh yeah, they look all good, and they wear out, they're going to just take out your injectors. So there's risks with trying to do things that you're not trained to do. Not to mention, we do not have the equipment to properly test an injection pump after rebuilding one. And they have the tools, but they say if you put something on there that's not done right, it will destroy the tool, take out the tool, because those things have a lot of load and have to be spun really hard and fast. So you'd have all the gears that could get taken out just by trying to turn a pump that seizes on you, which is why they don't want to take risks. They say, put it on your car, see if it works. If it works, it works. But if it doesn't, it'll take out your car rather than taking out our machines, which are worth a lot of money, especially in repairs. So I'm trying to say, don't think just because I'm doing it that you could definitely do it. You need to have the training, you need to have some background with something, and you have to know what you can and can't do. I'm not 100% sure how well I can do this balancing, but as I do this, I'm going to identify if I can do it or not. I know I can probably do it, because I know these machines are for calibrating things, and I know that we can build a calibrating machine, and understand the fundamental physics behind it. Now, not everyone's going to understand how that works, but I sort of do. And I also know the safety and the risks and the dangers of it. So, with all these machines, they are all very, very dangerous machines. And I do know the dangers of them. This machine, I've almost hurt myself on a couple times. I've seen my dad in the workshop, and when the machine tried to grab him, he pulled his hand out and smashed his hand into a carbide cutter. And he's lucky he just got away with a bruise rather than cracking a bone when he hit that cutter. It's just like me setting up for this MLS head gasket. I'm doing this because, fundamentally speaking, I'm not just going to grind this and see if it looks good. I'm going to be grinding this to the point where, if it is within tolerances that I can put this together, I will. But if it's out, I'm going to take it to a machine shop when I can afford to and get it done correctly. Or, if possible, if it's still out, and Dad's willing to spend the money and get the head put on here that is in the back corner of this shop that's not very good, it needs bearings in it. If we rebuild that, mount it here, we could potentially do it here and machine that deck right here on this machine. So, fundamentally speaking, I am doing the right thing. I'm doing things that people tell me, they're saying to others, don't do this, you shouldn't do this. But I'm saying, yeah, I agree, you shouldn't really do this stuff, but I'm taking my precautions in case I don't believe it's adequate. Like, I know I'm on a budget, I can't afford to machine it, I'm going to try this. If I don't like it, if I know that this head gasket is not, this deck is not within tolerance for this head gasket, I am definitely not going to use it. And I'm going to pay attention to all the fine little details because I don't really want to stuff up. If you know my history of my car and me, you know it blows a lot of head gaskets, and I really don't want to keep having that problem happening. I've spent money on it, and money for me to make is really, really hard work. So do I really want to take the shortcut and then have to spend even more money or twice as much money as I've already spent to fix things or get it running right? No. I want to take my precautions and be certain of things, because I could spend money now, it looks like a lot now, but if I go and tee things off, if I took two different paths, say I'm in two different realities, one path, I'm poor now, like this is kind of the reality now, I'm poor now, I can't really afford these parts, and I'm going to get the correct parts rebuilt by professionals and spend, $3,000 on this stuff. Whereas if I tee up and go down another path, I'm going to be like, nah, I'm not going to rebuild the injection pump. It works, it's fine. She'll be right, mate. The turbo's, a bit worn out. I'll try to rebuild it and use it, forever sort of thing. Down the line, one of those two paths is going to last, and one of those two paths is going to cost money. So if I want the most longevity out of my car, the path which I'm going down currently is the right way, whereas the other path, down the line, it could cost me another, $9,000 on top of what I've already spent. So I'm looking at it this way. I could spend $9,000 now, and it will last me 200,000 kilometers, no problem. I will just have to spend money at the 200,000 kilometer mark to properly repair it. But if I go down the other path, the darker path, I could spend 9,000, 7,000, 6,000, 5,000 now, and try to, half-ass things. I don't know condition of the injection pump. I don't know how long it's going to last, or if it's going to take out the injectors. I don't know if the head gasket's going to blow. I don't know if the turbo is going to blow, because I haven't looked, and I haven't thought about rebuilding that stuff. Or I have rebuilt it, but I don't know how long it should last, or how long it's going to last. I haven't done it properly, or whatever. And, anywhere from your go line it to the next 60,000 kilometers, something's going to go. Injection pump, if that seizes up or loses compression, it can't pump oil anymore, it's going to likely say, I got to replace the injectors again, the pump, it could take out the head gasket, if the pump seizes, it could take out my gear set for the cams, and then I have to hunt around for those parts, and it could cost me, another $3,000 just to get that all going again. But even worse, if the turbo lets go and that shrapnel goes into the motor, that could take out, another $3,000 worth of parts. So that's $6,000 extra on top of the $5,000 I've already spent. So that's $12,000 I could spend within the next 12 months, who knows how long. And it could even cost more down the line. So $9,000 that will last me 200,000 kilometers is a lot better than me spending $12,000, and it's going to not last me 200,000 kilometers. So that's the thing I'm looking at. The longevity of my parts, the considerations are now to take rather than down the line. I've been doing this as best as I can. I've kept my car going as long as I can. But now I've got the new injectors. I'm reluctant to put them back in. I'm reluctant to put the turbo back in its condition it's in now. I'm reluctant to do anything in my car with that wastegate being malfunctioning and the cracks in it that, could take out the blades and then throw the thing out of balance and blow it up. I don't want to take the chances because I want to be able to reuse any spare parts I can from both the vehicles, from both the engines, to make a good engine and then potentially build another one down the line when I can get the parts. So I really just hope people understand that's my way of operating. There are people out there that do not operate in that way, and they'll have this trial and error thing where they're going to try something, see how it works, cost some money, and they've blown something up. People like blowing things up. It's fun to watch things blow up, but when you can't really afford it, when you're on a tight budget, and you want something done right, you need to actually do it right. Don't take shortcuts. I mean, I'm not taking a shortcut. This is actually taking half an hour per sheet to do this. So this is not really a shortcut. This is just me trying to work around my budget as it is. It's really tight, and this is a very long video. This is me trying to do something with the time that I have currently that I'm not going to have in the near future. This is me trying to get by with this current situation, with work, with the coronavirus, with everything. And most importantly, the fact that I can't drive a ute to take that to the machine shop, that is the biggest reason why I'm trying to do this way. And if this doesn't work out that way, we've got a machine. We could eventually get this operating correctly and actually machine the block ourselves and do things ourselves. We're not, my dad's the professional. He can machine this. He knows the feed rates. He knows how to calculate this stuff. He has the books, the manuals, if he needs to. They're mostly at work, though. I have a manual somewhere on Metalwork, but I can't find it. The damn thing's hiding. But he always tells me, if you're not sure about something, to go read up about it. Now, I will take this to the last level of what my dad does. He knows his threads inside out. He knows his numbers inside out. He still has Zeus precision books for when he's making, threads, like pitches, thread types, this and that. And he also has this book on, apparently, going metric. I'm guessing because metric was the thing they were changing to from imperial, because it's the standard these days. He has drawers full of taps. He has manuals with his taps. He does a lot of things. He has manuals somewhere else as well, but yeah. And he's also done the research and homework into his turbocharging. He's got books on that stuff. He's read into it. He knows a lot of things, and he'll be able to contribute a little bit. Although I don't really want him 100% to help me with much stuff, because he's sort of damaged our relationship as father and son quite a lot. I'm willing to talk to him, discuss things with him, work with him on some stuff. The only relationship I'd ever have with him that is, working together is if it's a business sort of thing, where we're both going to be making something for money to help us survive and help keep these things going and to keep fueling our passions. But we don't have the kind of relationship anymore, because it was a very unhealthy one, and I don't really want to go down that path again with it. So it's one of those things where I will keep my distance as best as I can and do what I can on my own. And when I need the help, I'll try to talk to my dad. And if I can't talk to him, I'll have to just do my homework. And I'd rather just do the homework than have to rely on others, because there's been a lot of people who have literally done something to hurt me. And that is one of the reasons why I try to be, reliant on myself, 100% reliant on myself. Because it's not the greatest experience when people backstab you and give you hell and use you. Because the thing is, I look at it this way. We have these tools. And then there's people who want to use these tools, but they want to be like freeloaders. They want to make frets, right? I have that turbo. And when people want to make these frets, if I cut them off, there's these things that they lose access to. I'm not going to lose nothing. I lose a old friend who made a fret to me, okay? They made a fret to me, they're not friends. Okay, that's the way I look at it. Someone made a threat to me. They wave to me every now and then still. But they made a threat to me. They're not a friend. And that was hurtful. I have a real friend, okay? His name's Lachlan. And what he does is he still works on games with me, sort of. He doesn't really want to work on the same project as me. It's not his interest. But I asked him if he could make something. And I said, I don't care the condition. I just want a placeholder. And he's done that. He's made a placeholder. It's not the greatest looking thing. It's not what I envisioned. But he's done something to help me out. And I kind of feel like I'm compelled to try and do something to help him out. And sometime he will eventually come around to our place. Maybe when the coronavirus is over. He wants to see us pull our fish. Because everyone's interested in that stuff. But I've talked to my friend a lot about my motors, my car, and all of this stuff, and how it's stressful, and he understands. He's a very understanding, very forgiving person, and I do want to help him out as much as he's been helping me out. And that's the thing. I now feel like I owe him, because when I've been financially struggling, he's, been the guy to fork out $1 or $2 to get me something to, a bite to eat or something. And I feel compelled to buy him something back. And I've managed to do that a couple of times in the past. I haven't seen him for a while in person, but I'd still, if I had the money, which I don't, I would. But my priorities are to keep reliability of my car and get that going and make sure I can reliably get to work, get home, and do everything I can with my car rather than focus on just food and meeting and hanging out. Because if that breaks down, I lose my line of income. I'm focused on my line of income, and that means I'm empowered to go and collect materials, to be constructive with myself, and then feel relieved that I'm not going to have any problems, and then I can feel free to spend as I want to rather than how I need to. Like, this is something I need to do, but it's also something I want to do. It's a two for one sort of deal. Like, I thought about it like that. My car, my engine, rebuilding it is a 2-for-1 deal because I need it rebuilt, but I want it rebuilt. I could have bought another car with the money I've spent on it, but why did I choose not to buy another car? I've had enough of buying other people's problems. It's a big reason why. So, I don't want to buy another car. So, I got 2 choices. You need a car. You either buy a car, nope, or you fix your car, which is what I've been doing. I'm trying to fix my car, make sure it's reliable, maintainable, and all that stuff. And I know my stuff well enough that I can get by. And if I was to spend the money on this car, it's going to cost me probably more than any other car. But at least I don't have to buy the other car and learn about it in order to fix it. I've already done the learning with this car. I know this car well enough that I can fix it myself. Which is why I'm taking the leap at my car and doing it now. Because it has been fun to drive. It has been awesome. It's done me really, really well. And with all the problems it's had, even the ones I don't even know about, it's driven really great. I haven't really noticed any issues with it. And that's the thing, because when this is all refurbished, this is all put together, the exciting thing is, I don't know what to expect. I don't know how this is going to perform. I don't know if it's going to pull up the hill or struggle up the hill. I don't know what normal for this car when it was new is going to be like. Because I've seen all these other cars and they look like crap. And they're the same engine and all that whatnot. They wanted a lot of money for those cars. And when I saw those cars, I was like, I don't want this. This is disgusting. And when we got offered that car for that money, mate, it was too good to be like, yeah, I want to salvage this. I'm going to build another car. It was just too good. And I got exactly what I wanted. A dual cab ute. And my mum wanted me to get... wait, is that right? It's a dual cab ute. I'm lost. Well, mum wanted me to get a 5-door ute, okay? I'm confused with the utes now, the body style and stuff. Oh, dual cab is, rear and front cab thing. So this is a single cab ute. Sorry, I keep saying... See, I'm already lost. I don't even know what things are anymore. This is a single cab ute. I got exactly what I wanted. I wanted a single cab ute, 2 doors, huge tray to carry stuff on. And I got it. And then my mum wanted me to get a dual cab ute because, what if someone needs to go to hospital and someone can sit in the back with someone who's sick or something. That's the way she looked at it. But I looked at it like this. I wanted a work vehicle. I got my work vehicle. And it's fun. And it means work would be a little bit easier with it because it's fun. There's only one downer to it. The work vehicle kept breaking down. It kept being stressful when it did break down, when it had issues. And the stress of potentially destroying this was unbearable when I was working and I was spending... I was expending myself in too many ways. One, I was expending myself to work emotionally because they were giving me crap and grief and blaming me and stealing from me. Like, maybe not much, they haven't stolen much from me, but they did. And they never informed me of anything, and they kept giving me the runaround. that's pretty much really what it was, mostly. So those were the few factors. I thought I was going to be like 1, 2, 3, 4. No, I said it all. And then on top of that work, I had this giving me the grief. And I had the problems with, I don't want this to break down. I want to keep this going. I want to keep earning money. And in the end, I didn't save any money from that job. The money that I got from my grandparents that helped me out, I got a whippersnipper with it. And I took that whippersnipper up with my own pops and I went to try and do some help. And it worked pretty well. They thought it was crap because they have a feel and that worked better. But yeah, it's nice to ramble and have some fun talking about some things, but sometimes it's a little bit depressing. But we kind of get the points across that we need to when it comes down to it. The project vehicle, family vehicle is right there. And it's going to be a long-term project where everything gets reconditioned. That one is a project beyond this one. This one's just, oh yeah, I'm going to recon an engine. It costs $9,000 potentially, $8,000 potentially. Who knows what the price is at the end? I don't know. I'm still waiting for prices on things. And then we have, what is it? We have the transmission upcoming. That will probably cost $1 to $2 grand to rebuild. I think I estimated it was actually $2 grand to rebuild my transmission in my car. Yeah, so that's that case and scenario. But the Ford Fairlane needs something along the lines of currently it's $10,000 in body work. Then you got to add on another $10,000 paint, so it's $20,000 in the body. It will probably need all new suspension components, so that's about maybe $1,500. Then it's going to get the engine overhauled, which will be, about $3.5 grand. Transmission overhauled, $2.5 to $3.5 grand, so we'll call it $7 grand, those two components together. The diff's going to get overhauled, which will probably be about $3 grand. So that's already $10 grand there, $10 grand there, $10 grand there. So there's already $30,000 in repairs and upgrades and whatever you want to call it. All the interior components are going to get repaired and replaced. That's $10 grand again. So we're up $50,000. And I think wiring maybe $5,000. So $55,000 to $60,000 it will cost to recondition the whole ZL Fairlane by professionals, not personally just me. It'll be me sending all the stuff out to get done rather than me doing everything myself, if I want to go down that path. I think that's the best path I should take when I do that, because I might have other important things to do and it might be just worth my while just send it out instead of doing it myself. So thank you all for watching, thank you for participating and your support. I hope there was something useful you could take away from this video today. There's my whippersnipper right there. But we're going to be cleaning up the shed once this project's over. We're going to be rebuilding this table on this mill. And we're going to have other projects sooner or later that we're going to have to deal with. And now we're going to hurry up and finish as much of this engine off as possible and get it all ready to drive. I might use the injector pump on my car for a little while, but that's about it. So thank you all for watching. Thank you for participating. This is Micro Mechanical signing out. Have a good day or night wherever you are in the world. Peace.